Hi everyone, I am Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Today we are going to discuss about Cauchy residue theorem. First problem is evaluate integral over c equal to divided by z plus 2 into z plus 1 the whole square into dz plus c is the circle with mod z is equal to 3. First you have to write the Cauchy residue theorem formula. Cauchy residue theorem formula is integral over c f of z dz is equal to 2 pi I into sum of residue of function inside C. Cauchy residue formula is integral over C f of z dz is equal to 2 pi I into sum of residue of function inside C. First you have to take the function as f of z is equal to integral over c e square divided by z plus 2 into z plus 1 the whole square. First you have to find the poles for this function. To find the poles of the function, we have to take the denominator term. The denominator term is z plus 2 into z plus 1 the whole square is equal to 0. First you have to find the two poles for this function. First I am taking z plus 2 is equal to 0, then I get z is equal to minus 2. Here z is minus 2. The order of the power of the function is 1. So the z is equal to minus 2 is the pole of this function with order 1. Next z plus 1 the whole square is equal to 0 means z plus 1 is equal to 0, z is equal to minus 1. Here is the order 2, power of the function is 2. So it's a pole of z is equal to minus 1 is a pole of order 2. Next we have to find the function lies inside C or outside C. So I am taking the function z plus 1 into z plus 1 whole square into z plus is equal to 0. First I am taking the given condition is mod z is equal to 3. Given function is mod z is equal to 3. First I am taking first function is z is equal to modulus of 2. Then here I get 2 which is less than 3. If the function 2 less than 3 means it lies inside C. Next mod z is equal to 3. Here value is 1. We take modulus 1 means value is 1. Here 1 is also less than 3. Lies inside C. Next we have to find the residue for these two functions. First I taking the function z is equal to pole is equal to z is equal to 2. Here z is equal to 2 means I have to find the residue for this function. If z is equal to 2, which is a pole with order 1, then formula for residue of order 1 is limit z tends to z naught, z minus z naught into f of z into dz. This is the order 1 formula for residue. Then applying the value of z naught, which is z tends to minus 2, z minus of minus 2 into f of z is given function is e power 2 divided by z plus 2 into z plus 1 the whole square. Next minus minus will become plus. So I am cancelling this z plus 2 and this plus 2. I will get limit z tends to minus 2 e square divided by z plus 1 the whole square. Next I am applying the limit of z minus 2 in this equation. So I get e power 2 divided by minus 2 plus 1 the whole square. Then it becomes e power 2 divided by minus 1 square. Then I get the value is e square. So next finding the residue value is z is equal to minus 2 means residue is e square. Next I have to find the residue for this function z is equal to minus 1. When z is equal to minus 2, the residue value is e square. Next I am finding the value residue for z is equal to minus 1. Order is 2. When order is 2, the formula is z is equal to minus 1. It's of order 2. Order 2 formula is of f of z into dz is equal to 1 by m minus 1 factorial limit z tends to z naught d power m minus 1 into dz power m minus 1 z minus z naught the whole power m into f of z. This is the formula for residue of order 2. Here m is nothing but order. Z minus value is minus 1. Applying this function. So m is 2 order 2 minus 1 factorial into limit z tends to z naught value is that point minus 1. Then d power m minus 1 means 2 minus 1 divided by dz power 2 minus 1. Z minus z naught value is minus 1, it becomes 1 the whole power square. F of z is given function is e power 2 divided by z plus 2 into z plus 1 the whole square. By cancelling this z plus 1 the whole square and z plus 1 whole square, finally I get 1 by 1 factorial limit z tends to minus 1 d by dz of e power 2 divided by z plus 2. I have to differentiate this term with the u by u formula. I get limit z tends to minus 1. U by v formula was v z plus 2 u dash e square. Next minus u v dash divided by v square. Next I apply the limit z is equal to minus 1. So I get minus e square. I apply the z minus 1 in this term, I get minus e square. Next the Cauchy residue formula is when z is equal to minus 2, residue value is e square. When z is equal to minus 1, the residue value is minus e square. Now applying this in Cauchy residue formula is 2 pi into sum of residue of functions. So 2 pi I into first residue value I am getting is e square. Minus second residue value is e square minus e square. So e square minus e square gets 0. So 2 pi into 0 is equal to 0. This is the residue Cauchy residue value for given function. Thank you.